I'm going to go over one of the questions from our classwork from chapter 10. And essentially what I'm going to do is kind of show you the step-by-step process where I'm going to re-express the data. So I'll be referring to, if you want to have your notes out with you, I'll be referring to the lecture notes, what we call the ladder of powers, all right, to help me try to figure out what's going to be my best re-expression. And literally, guys, what I do is I go from the raw data, which is this power of 1, I go up to square to see if that helps. Then I go down to the square root. Then I try the logs, which then I'll be referring to this slide about using logarithms. And then back to, if that doesn't work, the reciprocal square root, and then essentially the reciprocal of the data. So it's really just following the step-by-step process until I find the one that I think is going to work the best. So I went ahead and I typed in the data for this first one. All right, talking about year explaining population in millions. Let me get that for you. There we go. So you'll notice that my L1 has starting with 0. So this is going to be years since 1950. So that 1950 is 0 years since 1950. So that's why I put 0 there. And then my Y values are in my list 2. Don't forget, I've already done the diagnostic on. So if you haven't done that, just go ahead and try. So now I'm going to just take a look at the the scatter plot to see if it's okay to make a linear model. All right, so hit graph, zoom, and 9. All right, and it looks like it is linear, it looks strong, and it looks positive. So let's go ahead and run the linear regression. So number 8. All right, go down to calculate. And I'm doing this because I need to check the residuals plot to see if I'm okay to use this model. So I'm going to go down now to stat plot and do the residuals to see what happens. All right, so I'm going to hit second list and do number 7. And now I'm going to graph it and see and hoping, remember, fingers crossed, I see no pattern. Unfortunately, right, this is a pretty distinct curve pattern. So I'm going to need to re-express this before I go ahead and use the model. So what I'm going to do, as I mentioned, referring to these notes here, I'm going to first try squaring my Y values. All right, so I'm going to go back to my calculator, and where it says population, my list 2, I'm going to do a new list in list 3 where I square all of those populations in millions. So go to stats, edit. So now here's how you do it. This is the first time you've seen this. So go up to where it's highlighted on list 3. All right, and you're going to hit second number 2, which is list 2, and this button here kind of to the corner of 7, which is the X squared button. I want to square all my values in list 2. Then hit enter, and it will take all of your values and square them. All right, so now I'm going to go back to doing my stat plot because I want to do check the scatter plot to see if that made it linear, or keeps it linear, I should say. So now I'm doing list 3 for my Y value. So hit graph, zoom, 9. And unfortunately, this actually looks like it's kind of created a little bit of a curve. So it made it less linear. So guys, if it makes the original scatter plot less linear, then you definitely don't want to use that re-expression. You don't even need to take the time to run the regression model and then check the residuals because there's no reason to use it if it makes it less linear. So let's go back now and do the next one, which is going to my notes, my ladder of powers. The next one after that is going to be taking the square root. So I had the raw data, the residuals plot showed a pattern. I try the squares, made the scatter plot less linear. So let's do the square root of our Y values. All right, so I'm going to go to the calculator. I'm going to do list 4 now. And then this is the square root. So hit second square root. And just kind of remember where your original Y values were. They're in list 2. So second number 2, which is going to be the square root of all those data values. All right, so I put them into list 4. So now let's check the scatter plot. So now I'm doing list 4. All right, and list 4 is going to be second number 4, hit graph, and then zoom 9. Okay, and that actually looks like I made it even more linear, so I feel good about this. Let's run the residual, or let's run the linear regression model. So that's calculate number 8. Make sure you scroll down and make this list 4. And just in case this one ends up working, I'm going to store this into my y sub 1 like we've done in the past because it's asking me to model, like to use the model on a question here. So I have y sub 1 and then hit calculate. Okay, so if I'm going to use this, we need to make sure that I'm going to turn this off just for a second. So when I graph the residuals, we're good. So we need to make sure the residuals plot is showing no pattern, or at least what I'm hoping, fingers crossed, is less of a pattern. That's the hard part here, guys, is that essentially there might still be a pattern, but does it look less curved in that pattern? So hit graph, zoom 9. And it's still not great, right? You can still kind of see maybe there's a little bit of a pattern, but it does look a little bit better in terms of less of a distinct curve. So I'm going to go ahead and go with this one. All right, so I'm going to write down my numbers here from this regression equation. It still should be in list 1, or excuse me, in Y1. So I'm going to write down my answer, which is going to be for my model. Now keep in mind, normally I would write pop hat, but because I decided on the square root, it's going to be the square root of pop hat equals 49.631 plus my slope is 0.566. Again, I'm rounding, but when I use the model in my y subscript 1, it's not going to round. Times, and now this is important, right? I'm going to put years since 1950, right? Because remember, I scaled them, right? It asked me to scale the years. So just keep in mind, if when I plug in this 2005, that is 55 years since 1950. So I'll be doing the square root of pop hat equals 49. Again, I know this is rounded, but my calculator is not going to use any rounding. Times years since 1950 would be 55. All right, so let's go into the calculator, and I'm going to hit vars, y vars, function, y sub 1, right? That's where I put it, and I want to evaluate this at 55. All right, so now be careful here. What a lot of students will do is when they do this on the AP exam, right, again, you're not going to have to type all this stuff in, but if you're using a re-express model, they're going to say that, oh, the population in millions in 2005 is 80 million. Now, just notice, right, the numbers in our table have been, for the most part, increasing. Looks like every single year. Just want to be sure. Yep, it's gone up every single year. So I should expect in 2005 to be over 6,057 million, so 6 billion. Right, so it's not going to all of a sudden just be 80 million unless there's some giant, event that wipes out that many people. So what I want to make sure you understand is that this is equal to, so that's equal to the square root of our predicted population. So it's 80.738 is the prediction for the square root of it. I don't want the square root of it. So go back to your days in algebra. I am going to use my algebra knowledge to square both sides. And this will give me the prediction for my population in 2005. So I'm going to go here and hit squared. And so we're predicting 6518, and I'll round to 6519 just because the rest of the table is not having any decimals. So 6519. And then in millions, right? So really the billion, right? But the idea is, you notice, right, if I were to put that in the table here, I'm going to erase it, don't worry. But when I put that in the table, that makes sense, right? It has been increasing. Just to let you know, this is something that we talked about in chapter 8. But you want to be careful about predicting and things like this, right? Because our model only went from years 1950 to 2000. So if we're going to predict like year 1962, that makes sense to me because it's within my range. But 2005, or if it asks me to predict 1920, right? I want to be careful because that is what we call extrapolation. So this prediction here in letter B is definitely an extrapolation. So you want to be very, very careful in terms of using the model, and really you just want to avoid doing that at all possible, if at all possible. avoid extrapolating. It's only going to get you into trouble because we have no idea. Like I mentioned, there could be a world event, right? The pandemic happened. It's still, still people are struggling with COVID, but that event that happened at the end of 2019 into 2020 and beyond is going to have an effect on the population for years to come. So, you never know what could happen. So extrapolation is always something to be cautious about. All right, so that's it for this one about world population. Check the next videos for the next two examples from this classwork.